Hello, Mr. Holmes here. Hopefully this is going to be a rather quick video of no more than about 10 minutes explaining some very important concepts that you need to understand in order to move forward with your project. Projects by their nature, unlike everyday programs that we've written so far, are much more complex, more involved, and a bit more like real-world programming. So you will remember that when we started coding, we talked about the DIPO process, which stood for we declare our variables and we then broke our program down into three main phases: input phase, process phase, and output phase. When it comes to more complex problems, we replace the different phases with subroutines or procedures. The declaration becomes our global variables, and we then need to define procedures for each main step. Bear in mind that the goal of defining procedures is to actually do something called divide and conquer, and that is to break the problem down into smaller, more manageable steps. So what we want to do is to break the problem down into smaller steps, each of which is simpler to solve than the overall problem as a whole. And so when we do this, you need to try and keep the role of the task you are performing with each of your subroutines to a minimum. It should be as simple as possible and only focus on solving one or at most two or three main sub tasks. Right, now it's hard to talk about these things in a vacuum, so I've introduced a word problem that is roughly around about an L level program, which says prompt the user to continually enter whole numbers. As soon as 0 or a negative number is entered, input should stop. Display the sum and average of the entered numbers. At least 3 numbers must be entered before input is halted. Now, we don't want to spend a whole lot of time on analyzing it, but basically it boils down to the following main steps. So we're going to repeatedly enter integer numbers. We're going to add the input data numbers if they're positive. We're going to count those numbers if they're positive, and stop only when count is greater than or equal to 3, because I'm going to count each valid number that I've entered, has been entered, and the value of data is less than or equal to 0. That will signal that the person wants to stop entering numbers. Once the loop has been terminated, this is, by the way, a conditional iteration loop. Once the conditional iteration loop stops, the program must then output the sum and the average of the entered numbers. With a quick bit of thought, the following variable table helps us solve the problem. We have a data variable which is an integer, which will store the numbers that we're entering. It's an input. We're also going to have two process variables: count, which is going to be an integer and which will count the number of valid inputs that have been entered. Quit is going to be a Boolean variable, which will be assigned the value true when data is less than or equal to 0 and count is greater than or equal to 3. That didn't come up. Sum will be an integer value that is going to be processed and outputted, as well as average. But average, remember, is always going to be a float because you're going to be doing real division when you calculate the average. So averages are always of type float. Right, so as I've said before, the emphasis of this video is to explain how to come up with your subroutines and understand what they do. So we're moving away from just putting everything in the main program, input phase, process phase, output phase, and into declaring global versus local variables. And we then are going to have input procedures or process procedures and output procedures. Notice I use the word plural. I might only have one input procedure, but I may need many. May have one process procedure, or I may need many. Likewise with outputs. How many do you need? Well, it depends on how you want to break the problem down. It's entirely up to you, but the general rule is you need to divide and conquer the problem into small, manageable steps. So here are some quick rules that you probably should take notes on about how to do that. Subroutines must do one or at most a few tasks, but they must do it really, really well. Hint, hint, in the context of your project, this could probably be lined up very closely against something in your success criteria. So you might write a procedure that deals with a particular part of your success criteria. You may need more than one procedure, but success criteria are a good way to help you break down and work out what procedures or subroutines you're going to need. Secondly, subroutines should only access global variables they need. You don't want a subroutine changing a variable when it doesn't need to. It should only use and modify the variables that it needs to work on. Any other variables that the subroutine needs should be made local. So they will be private to the subroutine and not interfere with anything else going on with the rest of the program as a whole. And finally, when we come to refine or define the subroutines, you need to remember that we are focusing only on the problem that the subroutine is meant to solve. You can therefore ignore everything else. So this is divide and conquer. This is abstraction. Right, so we have now our data variables table. We're now going to look at how do I break this down into subroutines to make that make sense. Right, the answer to the question is you need to break it down by starting off by answering the question what it does. What does it do? So just looking at my variable table, I obviously have a data variable, and so I will need something which is an input. I will need something to get the user input and store it in the variable data. That is going to be my first subroutine. The next question I need to answer is what global variables, if any, is the subroutine going to need to work with? And the answer is, well, obviously it needs to work with the global variable data. Does it need to work on anything else? The answer is no. So that is all I need to have in my global list. Finally, I now need to name my subroutine, just like I name a variable. So the way we normally do this is we use a input type verb and we then link it to what is it doing it to. In this case, we're going to be working on data. So I'm going to choose the input verb get, and I'm then going to attach to that the variable name that I'm going to be working on, which is data. So my subroutine is going to be called get data. Looking at my variable table, I can see I have a number of processes that I now need to work through. Some of them are related, and I can probably do more than one task in one subroutine, as long as I keep in mind that I want to keep it as simple as possible. Looking at the variable table, we kind of have the phrase count the numbers of valid data input captured for next to count, and we have the phrase sum all the valid data entered next to sum. So that's a similar sort of process. So that is certainly tells me that yeah, it's maybe a good idea to join those two variables to be processed together in the same subroutine. So I'm in fact going to do that. So I'll phrase it as follows: count and sum valid data that has been input. What do I mean by valid data? Valid data, data is data greater than 0, strictly positive. Right, looking at this, which global variables? Right, so let's talk about which global variables are going to be modified or changed or used by this subroutine. Very obviously, we're going to be using the value of data, but this subroutine is also going to be making changes to the count variable and the sum variable. However, if we look at it carefully, let's break it down and say, right, which variables am I going to change? The ones I'm going to change are going to be those ones. So in terms of good design, what we normally do is we say, right, if a variable is going to be used only as an input, then I should send it into the subroutine or the procedure as a parameter. Right, so now this is a process. So I need to use a process verb. So I'm going to use the process verb calc, and I'm then going to tag onto that. What am I going to modify? It's going to calculate count and sum. However, now, because I now have a parameter and it's going to use the input value of data. Alright, so let's just make our subroutine table a bit wider. So my procedural subroutine name is going to be calc count sum, and in brackets it will have the value of data. It's going to use data as the input parameter. Right, this brings us to modifying and working with the quit variable. So what it does is we want to set the value of the Boolean variable quit to true if count is greater than or equal to 3, because we want at least 3 inputs, valid inputs captured, and only when the data value is 0 or less, non-positive. Right, which global variables is my subroutine going to change? The answer to that should be very obvious. It should only be quit. And again, now I need to name my subroutine. So I will call it calc I can call it maybe find, just to be find, or this is do quit. In the moment, I'm going to just put open and close brackets. Right. Does my subroutine need any of my global variables as an input to work this out? And if I look at how I've stated it, yes it does. It needs to know what the value of count is. It also needs to know what the value of data is at the moment. And so those I can now add as parameters to my subroutine definition. So do quit count comma data. Right, carrying on in the same fashion, we now come to the final three subroutines that we need, and they involve, well, the sum has already been spoken for in one of my subroutines. I need to work out the average, and then I need to display the required data. So I need 2 more subroutines. Right, what do? The first one has to calculate the average, and the second one is going to be an output routine which will display the sum and the average. Right. Calculating the average. Which global variable is it going to change? It will change only the average variable. What inputs does it need? Well, it needs the sum, and it also needs the count. Because remember, how you're going to work out the average is you're going to divide the sum by the count. I need to name it. So again, calc average, AVG, I'm going to call it just to be different and show that it doesn't have to be exactly the same, but it does need to make sense in the context of the question. So I need the sum and I need the count, and that's the definition of my subroutine for calc average. And finally, the display sum average is not going to change any variables, but it will use. So it will use the sum variable and it will use the average variable. And I'm just going to call this display, and display what? Well, everything, but I'm going to be more exact about it, add exactness to it by actually specifying what it is displaying by giving them the names as parameters. I'm going to display the sum and the average. And that is the complete subroutine table definition for this particular problem.